In this class, we will discuss about different time estimates for a PERT time estimate. Different definitions we have to understand. So PERT means it is program evaluation and review technique. Program evaluation and review technique. That is the expansion of PERT. So you know about the event and activities for any project. We require certain time to complete the activity from one event to another event. So normally if you take 1 and 2 as the events, activity will join these two. So this is the activity. We require a certain time to complete this activity. So though that time can be defined in 4 different ways. The first one is the optimistic time. Optimistic time denoted by PO, optimistic time estimate. That's it. Optimistic time estimate. So it is denoted by PO. Actually, optimistic time is it is the minimum time or the shortest possible time in which an activity can be completed under ideal conditions. So this is the shortest possible time an activity can be completed. But under ideal conditions. So there should not be any delay or any problem during the conduction of that activity. That is the assumption. So it is only a theoretical thing. So it is the shortest time. That is very important thing. Without any obstructions or problems in carrying out the activity. The second one is the pessimistic time estimate. Pessimistic time estimate. So this is opposite of optimistic. It is the longest time. So TP you can call. It is the longest time or the maximum time that is required to complete the activity. Longest time required to complete the activity. So in this actually it is not under ideal condition. Taking into account the problems encountered during the conduction of activity. So this gives the maximum time, okay, conduction of activity. But actually in practice, neither the time is optimistic nor it is pessimistic. So it is only, both are hypothetical ones. One is under ideal condition without any problems. Another one is considering the problems. So because of the one more we are going to have, that is called as the most likely time estimate. Most likely time estimate. Most likely time estimate denoted by TL. Actually, this gives an idea what is the most probable time the activity can be carried out. It lies in between these two values. So, most probable time. Most probable time required to complete an activity. So naturally this value, PL value will be in between T0 and T. So that means T0 is less than TL less than T. So T0 is the minimum time, TP is the maximum time, TL is the in between T naught and Tp, so that suppose if you take T naught optimistic time, if you consider 4 hours, pessimistic time if you take 8 hours, your TL may be 6 hours. So this is without considering any problem under ideal condition. This is considering anticipated problem, and this is probability. So this value of TL lies in between T naught and T. So the fourth one is most important, which is called as the estimated time. So this is most expected time. Expected time. So fourth one is the expected time. So this is what we are going to use in PERT. Expected time denoted by TE. TE. Actually, this is the average time on a single workable time in which an activity can be carried out. Average or single workable time. An activity can be completed. So this TE actually is an average value of these three. Since the reliability of the importance of this TL is more compared to T naught and TP. So this is without any problem. This is considering problem. Problem may be there or may not be there. We are not sure. But this TL value gives almost most probable time. Therefore, weightage is more for TL. So this TE is calculated using this formula. More weightage is given to TL. T naught plus 4 times TL plus TP divided by 6. See, here this is the formula to find the estimated time for any activity. So you can see that the weightage for TL is 4 times more than the weightage for T naught and TP divided by 6. 4 plus 1 plus 1 6. That gives the average time which is called as the expected time. So this is most important for us. So to compute the critical path method or to review the technique of the program evaluation. Now suppose in this case, if I take this same example here, for this example TE can be written as T naught is 4 plus 4 times TL is 6 plus TP is 8 divided by 6. So the value of expected time will be 4 plus 24, 28. 28 plus 8, 36 divided by 6, that is 6 hours only. So 6 hours is the expected time to complete that activity. So by knowing the T naught, TP and TL, we can calculate the expected time for an activity. Now let us take a problem in which we can compute the expected time for different activities, because in any project the activities will be carried out in series. So when it is in series, so we have to calculate the time, estimated time for each activity, and then we have to add those things for different parts. So for different parts. For example, now we take up a problem here to calculate the critical path or to know the critical path, how it is done. So here the network for a certain project, network for a project is given. So the values of this times they are given like this. The time estimate values, that means T naught, TL, TP are shown. Determine the critical path. have to find the critical path. So critical path means which takes maximum time, that is sigma TE, maximum expected time. So whichever takes the maximum expected time, that is the critical path. That path is the critical path. Now the problem is given like this. The network is given like this. Event 1 is connected to event 2. Then 1 is connected to 3 also. Event 3. Then 3 is connected to 6. 6 is connected to 8. 2 is connected to 7. 7 is connected to 8. Then 1 is connected to 4. 4 is connected to 5. 5 is connected to 6. So this is the network given. So 1, 2, 3, 4 up to 8, they represent the events and arrows represent the activities. Now the time estimates for each activity 1, 2, 2, 7, 7, 8, 1, 3, 3, 6, 6, 8, 1, 4, 4, 5, 5, 6, they are given in this fashion. So first value, whatever you are going to write, that is okay. They are given in days. Let us say they are given in days. Time estimate is given in days. So 1, 2 is 6, 8, 11. That means for the activity 1, 2, optimistic time is 6 days. This likelihood time is, most likely time is, estimate is 8 days, and TP, pessimistic time is 11 days. Similarly, for conducting 2, 7 activity, 8, 10, 12. 8, 10, 12. So 8 days, 10 days, 12 days. T0 is 8 days, TL is 10 days, TP is 12 days. You can observe that there is an increasing order like this. T0 less than TL less than TP. Next is 5, 8, 12. 5 days, 8 days, 12 days. That is for the activity 7, 8. Then for activity 1, 3, 3, 7, 9. 3, 7, 9. Then for 3, 6, 8, 10, 12. 8, 10, 12. Then for 6, 8, 7, 10, 15. Then for 1, 4, 5, 7, 10. Then for 4, 5, 4, 6, 8. All are in days. Then for 5, 6, 3, 5, 6. So these are the timings T0, TL and TP for the different activities. It is given in the network. Now let us identify the paths. Now here the tail event is 1 and head event is 8. So this is starting of the project, this is ending of the project. It may be anything. So construction of a building like that. So initially starting can be taken as excavation of earth for putting foundation, and the ending maybe it is finishing stage. So in between there are so many events, casting of columns, beams, slabs, door, fixing of windows, doors, all those things will come, all these events. Now let us first identify how many paths are there from 1 to 8. So paths from event 1 to 8. So if you observe here in this problem, there are 4 different paths. Let me name them as path A. Path A is, I will start from 1 to 2, 2 to 7, 7 to 8. This is one path. Path B, I will take 1 to 3, 3 to 6, 6 to 8. This is the second part. Next, there is one more here. There is one more path here. Yes, this is also given 2, 6, 4, 8, 14. Okay. Then path C 1, 2, 6, 8. 1, 2, 6, 8. Okay. I will take this itself as B. This as C. And let us come in the order. Then path D. Path D 1, 4, 5, 6, 8. 1, 4, 5, 6, 8. Okay. So these are the 4 different paths. So which take place from event 1 to completion of event 8. Now for all these paths, we have to compute the expected time. T we have to compute. Then whichever gives the highest value of T, sigma Te, that is the critical path. Now let us we can carry out that in a tabular form. So I will take the tabular form like this. Paths. First column is paths. Second column T naught. Third column TL. Fourth column TP. Fifth column TE. That is the expected time. Now here what happens? First path is 1, 2, 7, 8. Path A. 1, 2, 7, 8. This is path A. So for path A, what is the value of T naught? So we have to take T naught values of all these. One for 1, 2, 2, 7, 7, 8. The first value represents T naught. So here it is. What happens here? We have to add them. 6 plus 8 plus 5. 6 plus 8 plus 5, it is 19. So 19 days. If you move along this path, the optimistic time, that is the shortest time is 6 plus 8 plus 5. That is 19 days. Next, we have to take the value of TL. TL is the middle value. 8 plus 10 plus 8. In that path, it is 26 days. Next, TP is the last value, 11 plus 12 plus 1. So which is 24, 35. So these are the values of T naught, TL and TP. Now you can compute TE using this formula. This formula is used to calculate TE. Now let us calculate TE for the path A. So that is T naught plus 4TL plus TP. T naught is 19 plus 4 times TL 26 plus 35. That is TP is equal to divided by 6. This average value 26.33. So all these values are in days. All the time values are in days. 26.33 is the expected time if you move along the path A to complete the task or project. Next, path B, I will take path B 1, 2, 6, 8. So on the same single lines, we have to compute now. So T naught for path B. So this is the path B 1, 2, 6, 8. So here also we have to take the first values 6 plus 4 plus 7. 6 plus 4 plus 7, which comes out to be 17 days. Is the optimistic time for path B. Next, TL. So 1, 2, 6, 8. Okay, TL is 8 plus 8 plus 10. 8 plus 8 plus 10. It is 26 days. Next, TP. 11 plus 14 plus 15. 11 plus 14 plus 15. That is 40. Now we will calculate TE using this formula. T naught is 17 plus 4 times 26 plus 40 is equal to divided by 6. So it is 26.83. 26.83 days is the expected time for second part, that is PB. Next to C. Part C is 1368. 1368. 1368. So TO values are 3 plus 8 plus 7. 3 plus 8 plus 7, that is 18. 18. Next, TL value 7 plus 10 plus 10. 7 plus 10 plus 10, 27. TP value 9 plus 12 plus 15. 9 plus 12 plus 15, which is 36. And T is once again calculated using this formula. T0 18 plus 4 into 27 plus 36 is equal to divided by 6. 27. 27 days are required. Then part D. Part D is 14568. 14568. So TO value is 5 plus 4 plus, there are 4 values here, 5 plus 4, 5 plus 4 plus 3 plus 7. For 10, 19, it comes out to be 19. Next TL value 7 plus 6, 7 plus 6 plus 5 plus 15, 5 plus 10. 5 plus 10. So that is 15, 21, 28. Then TP value 10 plus 8 plus 6, 10 plus 8 plus 6 plus 15. So 21, 29, 39. 39. Now TE value for part D is 19 plus 4 times 28 plus 39 is equal to divided by 6. It is 28.33. 28.33. Okay. So now actually this is your total estimated time. This is sigma TE only because I have added and then we have taken the average. So among these 4 values, the highest value is 28.33 days. This is the maximum value. Therefore, the critical path is D. D is the critical path. So we have to see that 28.33. So this is the critical path. So since part D takes maximum expected time, it is the critical path. So this is how we have to decide in a given network which path is critical path. So the path which takes care of highest value of sigma TE, that is the critical path.